Okay, guys, so my plan for today is giving you more examples of optimization problems. That means, in mathematical terms, that means finding the maximum or minimum of a function. And then after that, I'm going to begin a new topic. That's the L'Hopital's rule for the limits. So first, let me share my screen with you. Now you should be able to see my screen, right? So more examples of optimization problem. So here is an example. Imagine that a factory wants to make a cylindrical can. So the question is a cylindrical means you want to make a can which is the shape of a cylinder. Cylindrical can is to be made to hold 1 liter of something, like some, you can, for instance, of oil. Or water. So find the dimensions that will minimize the cost of the metal to make the can. So in mathematical terms, in more precisely, you have a can. Let me draw a picture for you. The shape of a cylinder. Something like this. But here is the problem is the volume of the cylinder is fixed and is 1. So the volume So volume V is 1 liter, is fixed, but the dimensions are unknown. We have to find the dimensions that minimize the cost of the metal. So minimizing the cost of the metal means minimizing the surface area of the can. So we can assume that the radius of the can, the circle, is R, and its height of the can is the cylinder is H. Okay. So what is the volume in terms of R and H, the dimensions? So the volume would be equal to what? It's pi times R squared times H, right? And we know that the volume is fixed, is 1, is equal to 1 liter, or in terms of meter cube, it's basically 1,000 centimeter cubed. Okay, so what is the relation between the radius and H, given that the volume is 1,000 centimeter cubed? So that means it follows from here that pi times R squared H must be equal to 1,000. So that means, for instance, we can say that from here, H is equal to 1,000 divided by pi times R squared. So based on the given information that the volume is 1 liter, which is 1,000 centimeter cubed, it follows that H is 1,000 divided by pi R squared. R is the radius of the circle, of the cylinder, basically. Now, what is the next step? We want to minimize what? We want to minimize the cost of the metal. That means we want to minimize the surface area. What is the surface area? So the surface area, I'm going to write it here, of the can is equal to, so the top part and the bottom part, the surface of, it's basically the surface of a circle. So, but you have two circles. One is on the top, one is on the bottom. So you have 2 times pi R squared. This is the surface of the top and the bottom. And the surface of the side of this cylinder is 2 pi R times H. So S is equal, so I call the surface area by S. So S is equal to 2 pi R squared plus 2 pi R times H. But here is the key step. From the given information, we know that H is 1,000 divided by pi R squared, right? Here is the key point. So that means S, if I want to rewrite S in terms of R only, S would be equal to, so S is a function of R, right? So I can say S of R is 2 pi R squared plus 2 pi R times H, which is 1,000 divided by pi R squared. So 2 pi R times 1,000 divided by pi R squared So this part would be equal to only this part. If you simplify, you get what? You get 2000 divided by, so pi is gone because you can cross out pi. And then you can also cross 1r from the top and bottom. So you get 2000 divided by r. Therefore, so you get S of r is equal to 2 pi r squared plus 2000 divided by r squared. Sorry, r. So that is basically the quantity that we want to minimize. So you see, I can write it in as a function of r. And r is, what is the domain of r? R must be something positive, right? So you have a function on some domain, so that means r is between 0 to infinity. So we want to minimize this. How to find the minimum of this function? Just compute the derivative, s prime. So s prime of r would be equal to 4 times pi r minus 2000 divided by r squared. So here we have to find the critical points. The critical points are those points at which either the derivative is 0 or doesn't exist. So s prime of r equal to 0. Let's solve this equation. S prime equal to 0. That means 4 pi r must be equal to 2000 divided by r squared. So if r is not 0, that means 4 pi times r cubed must be equal to 2000. So it follows from here that r cubed is 2000 divided by 4 pi, which is equal to 500 divided by 4. Sorry, divided by pi. That is r cubed. That means r is the cubic root of 500 over pi. That is the only critical point. You can also have r equal to 0, because when r is equal to 0, then s prime doesn't exist. When r is equal to 0, here, this is s prime. Look. Let me highlight. This is s prime. And you can see from here that when r equal to 0, s prime, because you have r squared in the denominator, so s prime doesn't exist when r is equal to 0. But r is equal to 0 is not in the domain of this s, the original function. So I don't need to worry about r equal to 0. However, it's useful to compute the limit of this function at the endpoints. So when r is 0 and r is infinity, and it's easy to see that the limit of s of r when r goes to 0, like 0 plus, this is infinity, positive infinity, right? Because you have 2000 over R. 2000 over R, when R goes to 0 plus is positive infinity, and limit of S of R when R goes to positive infinity, again, is positive infinity. And that's because of the 2 pi R squared term. When R goes to infinity, R squared goes to infinity. So that means at these two endpoints, R goes to infinity. These 2 points are the vertical asymptotes of S of R. I can even draw a graph of this function. And there is only one critical point, and that is the cubic root of 500 over pi. So this is the only critical point, and that is the minimum point, right? This point is the minimum point. So I can also draw the graph so we can see. And when R goes to 0, you have the S of R goes to infinity. So it's like this. So the minimum is what point? Here you have a minimum at this point, which is, this point is R equal to, this is R, and this is S of R. So R is third root of 500 over pi. So 500 over pi, so this number is something about 500 divided by 3 is like 100 and something, and then the third root of 100 something would be equal to about something about 5 or something. Okay. Anyway, so that's the minimum point, the minimum of S of R. But don't forget, the original question asked us to find the dimension. So not only R, we also need H. How to find H? Because we know that H is 1000 over pi R squared. We can plug R here to find H, right? So because we know that H is 1000 over pi R squared. So when R is equal to the third root of 500 over pi, which is equal to 500 over pi to the power of 1 over 3. So then H is and you can use your calculator to see what is this number approximately. Okay. These are the dimensions that minimize the surface area. R is this, and H. Okay, guys. That is one example. And I want to do two more examples. Another example. This example is very easy to state. So imagine that you have a point, you have a line. And let me draw this equation of the line. You have a line whose equation is given by, for instance, y is equal to minus 2x plus 3. So the question is, what is the closest point on this line to the origin? So find a point on this line. So this is the question. Find a point, or find the point on the line that is closest to the origin. Origin, I mean the point 0, 0. So I want to find a point on this line that is closest to the origin. So you know that intuitively, the closest point should be perpendicular, right? So if the blue line, so I want to solve this point in two ways. One is just the elementary school way, and another one using derivative. Okay. So I want to find the closest line, the closest point on the line y equal to minus 2x plus 3 to the origin. So I can use just the elementary school math. We know that the closest point should be perpendicular to the origin. I mean, the line that passes origin must be perpendicular to this line. So, and the point we are looking for must be this point, the point of intersection of these two lines, right? This point, the intersection. So how I find the point of intersection? Using only elementary school math. So the question is, what is the equation of the blue line? What is the equation of the blue line? Can you tell me the equation of the blue line? Remember, it's perpendicular to the green line. So the slope of the blue line must be what? What is the slope of the blue line? Blue line, which is perpendicular to the green line. What is the slope of the green line? -2. The slope of the green line is -2. The original line. What is the slope of the blue line? 1/2. Perfect. So, and because the blue line passes through the origin, its equation is just y, let me write by blue, y equals to 1/2 times x. So a line with a slope 1/2 that passes through the origin, its equation is y equal to 1/2 x. So you have two lines. One is, so this is the first solution. Let me write it here. This is solution 1. This is elementary. So you have two lines. One is y equal to 1/2 x. The other one is y equal to minus 2x plus 3. So you want to find the point of intersection. That means I have to solve this equation. Minus 2x is equal to, sorry, minus 2x plus 3 must be equal to 1/2 x. That means 2x plus 1/2 x must be equal to 3. So 5/2 x is 3. That means x must be 6/5. So x is 6/5. So y, what is y? So y is 1/2 x is 3/5. So the closest point to the origin on this line is basically the point with coordinates 6/5. So this point has the coordinate 6/5 and 3/5. Right? Okay. Now let's do find another solution that is more advanced using the functions and derivatives. So that is solution 2. So now here the question is, what is the distance if you have a point on this line, any point, I mean any point on the plane, what is its distance to the origin? So here we even don't need this line, the blue line. If you have any point on the plane, for example, look at this point. You have a point P with coordinate x and y. But be careful that because P lies on the line y equal to minus 2x plus 3, so the coordinate of P must be equal to x, and because y is minus 2x plus 3, so y is minus 2x plus 3. So any point, if you have any point, the distance r, so the distance between this point P and the origin, let's say r, is equal to square root of x squared plus y squared. But I know that y is minus 2x plus 3. So r must be equal to square root of because y is minus 2x plus 3. So r is x squared plus minus 2x plus 3 squared. So that means r is equal to square root of x squared. And if you do minus 2x plus 3 squared, you get 4x squared. 2 times 2 times 3 is 12. So minus 12x. And then you have plus 9. So r is equal to x squared. Sorry, 5x squared. Let's simplify it. 5x squared minus 12x plus 9. And x can be anything from minus infinity to plus infinity. So now here, what is the question? I want to find the minimum of this function, this quantity, because I'm looking for the closest point. The closest point has the minimum distance to the origin. So I'm looking for the minimum of this function. So here is basically the calculus question. Find the minimum of this function, r of x equal to square root of 5x squared minus 12x plus 9, given that x is in the interval from minus infinity to plus infinity. So what we should do, we should, as usual, we should compute the derivative and find the critical points. So what is r prime, the derivative? R prime is, this is a square root of something. So the derivative would be, I have first to take the derivative of what is inside the square root, which is 10x minus 12, and then divide by 2 times the square root. So recall that, just recall that if you have square root of u, the square root of u, the derivative would be u prime divided by 2 times square root u. Okay, so r prime is 10x minus 12, which is the derivative of inside square root divided by 2 times the square root of the original expression. So that is r prime. So I have to find the critical points. The critical points are those points at which either r prime is 0 or r prime doesn't exist. So r prime equal to 0 means if that is x is 12 over 10, which is 6 over 5. Right? How about, is there any point at which r prime doesn't exist? So that means here, basically, are there any points for which this denominator would be 0? So for instance, are there any x so that 5x squared minus 12x plus 9 is equal to 0? Do you think, is there any solution for this equation? No, because this quadratic equation has no solution, right? Grade 10, no solution. So there is That means there is no point for which the denominator of R prime here, this is R prime. The denominator of R prime would be 0. So the only critical point is the point at which R prime is 0. That is 10x equal to 12. X is 12 over 10. That is equal to 6 over 5. So that is the only critical point. And that should be the minimum. Because you see, you have the interval from minus infinity to infinity, and it's good to note that limit of Rx when x goes to either plus or minus infinity is both infinity. So this point must be the minimum, x equal to 6 over 5. As we found using the elementary solution. Elementary solution, we got the same thing, x equal to 6 over 5. Now, what is y? If x equal to 6 over 5, remember the equation of the line, y equal to minus 2x plus 3. Minus 2x plus 3. So y would be equal to minus 12 over 5 plus 3, which is equal to 3 over 5. So here the point that I have is the point 6 over 5 and 3 over 5. Exactly similar answer using elementary math. Any question? No question? Okay. So now I want you to give, I want to give you 2 problems. I give you 2 problems. I will let you know later what to do. Let me state the problems. Here are the problems. So problem 1. Problem 1 is saying that a right circular cylinder is inscribed in a sphere of radius r. So find the largest possible volume of such a cylinder. So I can draw a picture. So you have a sphere, first of all. Imagine that this is a sphere. Okay, and you have a cylinder sitting inside is inscribed in this sphere. So it could be something like this, for instance. So this is basically a cylinder. So find the largest possible volume of such cylinder. So the only thing we know is that the radius of the sphere is given. It's equal to r. The radius of the sphere is given and it's equal to r. And the second problem is this. Right. Circular again. Cylinder. Is inscribed in a cone with height h and base radius r. Again, find the largest possible volume. Of such cylinder. So here, this time, you have a cylinder sitting inside a cone, inscribed by cone. So how we can also draw a picture like this is my cone. And you have this time a cylinder, for example, like this. But this time you have the height of the coin, which is h. So the height of the cone is h, and its radius is r. For the sphere, the radius of the sphere is r. So the question you have to answer is to find the dimension and the largest possible volume of such cylinder. So for these two problems. So here, I want Kenny and Ryan work on first problem, and Cherny and Betty the second problem. Okay, Kenny and Ryan problem 1, Cherny and Betty problem 2. right? So Z is R divided by root 3. Now what is H and X? So H would be so the dimension of this cylinder in terms of H and X is what? So because Z is R over 3, X would be from here, X is equal to R squared minus, so X squared is R squared minus R squared over 3. So X squared is 2 over 3 R squared. So X is square root of 2 over 3 times R. And this is X, the radius of the cylinder. And H finally is 2Z. So H is 2Z, which is equal to 2 over root 3 times R. So you have H and X, the dimension of the cylinder. X is square root of 2 over 3 times R, and H is 2 over. So what is the volume, the maximum volume, V? The maximum volume V is just pi times X squared times H. So it's pi times 2 over 3 times R squared times H. So the volume, the maximum volume is 4 pi over 3 root 3 R cubed. Is that clear? Any question?